Okay, let me start with a question. Did you know that Mars has auroras, but they are completely different from the ones we see on Earth? Yeah, I bet most people imagine glowing green lights dancing like the Northern Lights, but Mars' version is way more chaotic. And here's the wild part. NASA's MAVEN mission just revealed why, and it's rewriting how we understand planetary atmospheres. This isn't just about cool space lights, it's a window into why Mars is a barren wasteland while Earth thrives. Let me unpack this. So, MAVEN was this badass orbiter that spent over a decade studying Mars' atmosphere before contact was lost in 2025. And even though the mission ended, the data it collected is still giving us mind-blowing insights. The big revelation. Martian auroras aren't just a weaker version of Earth's. They are powered by a scaled-down cousin of the same process that creates our auroras, called the Dungey Cycle. But here's the kicker. Mars doesn't have a global magnetic field like Earth. Instead, it's got these weird, scattered magnetic pockets left over from ancient lava flows. That's like having a patchy umbrella in a rainstorm, except the storm is solar radiation eating away at the planet's atmosphere. Let me geek out for a second. The Dungey cycle on Earth is this elegant system where the Sun's magnetic field lines reconnect with Earth's, accelerating electrons that crash into our atmosphere and create those glowing auroras near the poles. But Mars? It's like the cosmic underdog. Without a cohesive magnetic shield, the solar wind just tears into its atmosphere, stripping it away. And yet, auroras still form. How? The study found that those tiny crustal magnetic fields act like mini umbrellas, creating localized auroras. But the real shocker is that the same physics applies here. The Dungey cycle isn't just Earth's trick, it's a universal process that scales down to Mars' chaotic environment. That's huge. It means this mechanism could be happening on exoplanets, moons, anywhere with magnetic weirdness. Wait, but why does this matter? Well, think about planetary evolution. Mars wasn't always a desert. It used to have rivers, lakes, maybe even oceans. So what killed it? The lack of a magnetic field. Without that protective bubble, solar wind stripped the atmosphere, and with it, all the water. Earth dodged that bullet because our core dynamo kept spinning. Mars? Its core froze 4 billion years ago. That's a brutal fate. And MAVEN's data connects this to the auroras. Those glowing lights are literally showing us how Mars' atmosphere is bleeding into space. It's beautiful, and horrifying. Here's what fascinates me. The team used MAVEN's instruments to map these tiny magnetic fields, like forensic scientists reconstructing a crime scene. They had to push the sensors to their limits to detect these faint plasma flows. And when they finally saw the pattern, a miniature Dungey cycle in action. That's the kind of discovery that makes scientists geek out. But what's next? If this process works on Mars, where else does it happen? Venus? Pluto? Exoplanets around red dwarfs? This could change how we study atmospheres across the galaxy. Plus, for future Mars missions, robotic or human, understanding this interaction is critical. You don't want your astronaut's life support system fried by unfiltered solar storms. Let me end with a thought. Mars is a cautionary tale. Its auroras aren't just pretty lights, they are scars from a planet that lost its shield. And here's the eerie part. Earth isn't immune. Our magnetic field is weakening slowly. Could we end up like Mars? Probably not for millennia, but MAVEN's findings remind us. A planet's atmosphere is fragile. We take ours for granted, but it's the invisible magnetic shield that keeps us alive. So next time you see a photo of Mars, remember, those faint auroras are echoes of a world that once had a shot at life, and lost it.